Okay, so today we are going to start with linear differential equation. Okay, now what is linear differential equation? Try and understand very carefully. You have learned this concept in your 12th standard also. 12th में भी हमने सीखा था, तो यहाँ पर भी उसका एक sort of revision हो जाएगा. Now why this part is important? Because exam will contain one confirmed question on either linear differential equation or the next part of linear differential equation, which is called reducible equations, reducible to linear differential equation. And the third part is called Bernoulli's differential equation. Now all these things will require the concept of linear differential equation to be learned very properly. Now what is a linear differential equation? Understand carefully. Now there are two different types of equations that you want to learn in linear differential equation. As the name suggests, linear, that means you will have power 1. Suppose if I write an equation dy by dx plus py is equal to q. If you notice, there is dy by dx. This is the first order differential coefficient. Dy by dx is first order differential coefficient. Then the power of y is 1 here. And then p and q are some functions of x. Functions of x. Now try and understand the things very carefully. Dy by dx when I write, what do you mean by dy by dx? In dy by dx, y is called as the dependent variable. Y is called the dependent variable, whereas x is called the independent variable. So there is a dependent variable and there is an independent variable. So understand the equation according to its structure. Do not try to mug it. Do not try to memorize it. Try to understand the structure of the differential equation, because whatever types you are going to see, there might be different variables that can be used. For instance, in this case I have used the variables x and y. There can be another case where we might use some other variables, say r and theta, say x and t. Any other set of variables can come. So do not try to memorize this equation. Try to understand the concept very properly. What is it telling? It is having dy by dx. Now dy by dx, when I write dy upon dx, it means y is dependent variable, x is independent variable. So if you observe the entire equation, y was a dependent variable, the entire equation also contains a single y. There is a y in the equation. Similarly, I'm going to write one more equation. Observe carefully. If I write this time dx by dy, so again this is the first order differential coefficient, dx by dy. In this, x is your dependent variable. X is the dependent variable and y is the independent variable. See, the set has changed now. Independent variable. So the equation would now look like dx by dy plus, I'll modify a little bit, p dash, I'll write instead of p dash, dx by dy, x is the dependent variable, so x will come here, is equal to q dash. This time p dash and q dash, they are both some functions of y. So that's the difference between the two equations. Observe carefully. Here dy by dx, y is the dependent variable. So a single y will be visible in the equation. Single y, only y must be present. And lot of functions of x. Many terms of x will come and single y will be there. When I write dx by dy, x is the dependent variable. Single x must be visible in the equation. Only single x will be there and lot of functions of y. P dash and q dash are functions of y. Look at this example. Suppose if I write like this, I'll take this example. When I say dr by d theta, so as soon as you see dr by d theta, very quickly you should understand r is a dependent variable. If r is a dependent variable, the entire equation will contain a single r and lot of functions of the independent variable theta. So that means the equation would look something like this: dr by d theta plus pr is equal to q. So r was the dependent variable. So the entire equation contains a single r and lot of functions of theta. P and q will be functions of theta. So dx by dy, single x, dy by dx, single y, and functions of x, which was the independent variable. Dx by dy, single x, and functions of y, which is the independent variable. Dr by d theta, single r, which is the dependent variable, and P and Q are functions of theta, which is the independent variables. That is how the structure will always be looking for a linear differential equation. So it is very easy to identify whenever a linear differential equation comes. There will be one differential coefficient, there will be a dependent variable, there will be an independent variable. Whoever the dependent variable is, the dependent variable will be present in the entire equation alone somewhere. Single x, single y, single r. Similarly, there will be lot of functions of the independent variable. Here the independent variable was x, that is why the functions of x was present, p and q. Here the independent variable was y, that is why lot of functions of y, p dash and q dash were functions of y. Here the independent variable is theta, that's why p and q will be functions of theta. Now, in the entire differential equation, we always find the solution of the differential equation. We already know what is solution of a differential equation. So either I get the differential equation of the first type, or I get the differential equation of the second type, which are the basic types. How do I get the solution? Now, to get the solution, the first thing that I need to do is to find something called as an integrating factor. We already know this concept. An integrating factor will transform a non-exact differential equation into an exact differential equation. A non-exact differential equation transforms into an exact differential equation, and that work is done by the integrating factor. Integrating factor, here it is given by e raised to integration of p dx. Here, if I want to get the same integrating factor, I'm going to use the short form now, IF, it is written as e raised to integration of p dash dy, because y was our independent variable. Similarly, if I want to get the integrating factor here, so integrating factor is e raised to integration of p d theta. Theta was our independent variable. So that is how we get the integrating factor. Let's now see how to find the solution. So once I get the integrating factor, the next thing that I should be doing is to get the solution. Memorize one basic rule to write the solution, the basic formula to write the solution. I will use the same formula whatever question comes, whatever type I am solving. The same formula has to be used. The formula goes like this. The first thing that you should know is a dependent variable multiplies with the integrating factor is equal to integration of the RHS of the differential equation. So here the RHS is Q, here the RHS is Q dash. Again here I have taken the RHS as Q. So RHS of the differential equation. RHS of the differential equation, if you observe here, the RHS is a function of x. X is your independent variable. So this RHS will be a function of an independent variable. It will be a function of an independent variable. This RHS multiplies with again the integrating factor, IF, whatever you have found here. So IF will be written here. And then you will write D. Either I have to write dx, or I have to write dy, or I have to write dr, depending on who is your independent variable. So d, and you write independent variable. Understand the formula very properly. This formula you won't find anywhere else. So understand the formula very carefully, how it is written. The same structure I am going to use in any kind of type, any kind of question. Look at the structure one more time. Write the dependent variable. Look at the first type. This is our first type that we are looking at. In the first type, our dependent variable is y. So I'll write y into the integrating factor, which is e raised to integration of p dx. That is equal to integration of the RHS of the differential equation, which is q. And q is a function of x. X was the independent variable. Always, while solving a problem on linear differential equation, your entire attention must be on identifying who is the dependent and who is the independent variable, and where these have to be placed, where the dependent variable comes and where the independent variable comes. Look at the equation one more time. Dependent variable. In this case, dependent was y. So I have written y. Then into the integrating factor, which is e raised to integration of p dx. Whatever answer you will be getting, write that answer over here. Integration of RHS of the differential equation. In this case it is q, which is a function of x. Q is a function of x into the integrating factor, whatever the answer we have got of if, and then D, the independent variable. In this case, the independent variable was x, and you can observe also from here, Q was a function of x, integration of p dx, p was a function of x, integration of p dx, another function of x. So integrating factor is also a function of x, Q is also a function of x, so I have to integrate with respect to x, and x was my independent variable. So this is how you can remember, dx, and then obviously the constant will come. That's how we find the solution for type 1. Suppose I want to get it for type 2. Who is the dependent variable here? It is x into the integrating factor. Now for this, the integrating factor is e raised to integration of p dash dy is equal to integration of, who's the RHS this time? It is q dash. Don't you remember that q dash is a function of y? Q dash is a function of y into the integrating factor. Obviously we can observe integrating factor e raised to integration of p dash dy. P dash was a function of y, integration of p dash dy also function of y. That means integrating factor is also a function of y, q dash is a function of y, integrating factor is also a function of y. So I should be writing d y, and if you remember, look at the formula, it is written d independent variable. Independent variable was y, hence dy, and obviously plus c will be coming. That's how I write the solution for the second type. Suppose if I want to come here and write the solution, let's see how to write the solution for the last case. The solution here will be written as, who is the dependent variable? So the dependent variable is r into the integrating factor, which is e raised to integration of p d theta is equal to integration of the RHS, which is q, into the integrating factor, whatever answer you have got here. Q and p, they must be both functions of theta. Functions of theta. Now why they are functions of theta? Because theta was the independent variable. Theta was the independent variable. R was the dependent variable. It was a dependent variable. So R, IF, integration RHS, which is Q, function of theta. IF will also be a function of theta. I should then write d theta, and theta was my independent variable. So it definitely resembles my formula, and obviously I'll be putting plus C. So that's how you need to start with linear differential equation. There are three basic types. Basically you can say two basic types. The third one I have given as just a simple example. So whenever you want to get a linear differential equation, the more important thing you should understand is to identify dependent and an independent variable. So I hope you have understood how linear differential equations are to be identified. You can continue copying.